How old is everything we see around us? The galaxies, the stars, the planets, even the atoms in your body. The answer, believe it or not, is 13.8 billion years. But how can scientists possibly know that? After all, we can't rewind time and watch the universe begin. So how did we figure it out, with a precision of just a few million years? Today, let's explore how scientists uncovered the age of the universe, one of humanity's greatest scientific achievements. The question, how old is the universe, might sound simple, but it's actually one of the hardest questions in science. To find the answer, scientists used not one, but two powerful approaches. The first, by studying the oldest objects in the universe. The second, by measuring how fast the universe is expanding. Together, these two methods point to one incredible conclusion. Our universe began about 13.8 billion years ago in an explosive event we call the Big Bang. The first method relies on a simple idea. The universe cannot be younger than the matter it contains. Think about it. If we can find the oldest stars, they must have formed not long after the universe itself began. So, astronomers turned their telescopes towards some of the oldest star systems known, globular clusters. These are massive, spherical groups of hundreds of thousands of stars, orbiting galaxies like ancient cosmic fossils. By studying their brightness, temperature, and chemical composition, scientists can estimate their ages. Many of these stars are around 13 billion years old, which tells us that the universe must be at least that old, perhaps a little older. The technique works much like estimating a human's age by their wrinkles or hair color, except instead of years, we measure billions. But there's another, even more precise way to measure the age of the universe, by observing its expansion. In 1929, Edwin Hubble made a groundbreaking discovery. He noticed that distant galaxies were moving away from us, and the farther they were, the faster they seemed to recede. This meant that the universe is expanding, like a balloon being blown up. So if we know how fast it's expanding today, we can run the clock backward, shrinking everything until the galaxies meet at a single point. That's the moment of the Big Bang. The rate of expansion is called the Hubble constant. If the expansion were steady and uniform, we could easily calculate how long it's been happening. But there's a catch, it's not steady. When the universe first erupted into existence, it was incredibly dense, far denser than it is today. That high density caused gravity to slow the expansion down. Billions of years later, something unexpected happened. The expansion began to speed up again, driven by a mysterious force we now call dark energy. So, the universe's expansion hasn't been constant. It's been a tug of war between gravity and dark energy. To calculate the true age, scientists need to know not only how fast it's expanding, but also how its speed has changed over time. To solve this puzzle, scientists turn to the oldest light in existence, the cosmic microwave background, or CMB. This faint glow is the afterglow of the Big Bang, still visible across the sky today. It's like a baby picture of the universe, taken when it was just 380,000 years old. Two space missions, NASA's Wilkinson Microwave Anisotropy Probe and ESA's Planck spacecraft, mapped this ancient light in extraordinary detail. By analyzing tiny fluctuations in the CMB, scientists could determine the universe's composition, its density, and its exact expansion rate. The result? A remarkably precise estimate, 13.8 billion years, with an uncertainty of only a few million years. Think about that for a moment. From a small planet orbiting an ordinary star, humans have managed to measure the age of the entire universe, down to a fraction of a percent. It's one of the most incredible triumphs of human curiosity and science. We've learned that everything we know, every galaxy, every star, every atom, has been part of a 13.8 billion year cosmic story. And that story is still unfolding. When you look up at the night sky, remember, some of that light began its journey before Earth even existed. We're not just living in the universe. We're living within its history.